Hey everybody, this is Larry. This is me doing whatchamacallit? The premium weekly question. So yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's premium weekly question. Yeah, 1428, leftmost column with at least a one. So we have a row sorted binary index, meaning that all elements are zero or one on each row of the matrix is sorted. Okay. And basically you want to return the index of the leftmost column with a 1 in it. The row or the row index of the leftmost column. Oh, and we're getting these whatchamacallit, this is an API, binary matrix an API, you get the dimensions. Okay, so I mean, first of all, let's get the dimensions. I haven't thought about it yet. Hang on. But element of the matrix at index. I mean, I think the thing that special after I read a little bit more, I guess I should finish reading it first. But basically, after 1,000 cores, so basically they want you to. I don't know what the constraints on R and Z 100, but yeah, but they basically want you to do better than obviously linear time, where linear is R times C, where you look through every element. So okay, so let's take a think, right? So, can we walk? So for me, there are only two, or not only, but two strategies that I'm thinking about in my head. One is walking, meaning some sort of way to do one by one. So you do R plus C. Another way is maybe some way of doing binary search, so that you can kind of figure it out how to, well, just binary search on it. Given a row sorted, maybe I'm misunderstanding this. What is this row? Row sorted means that all elements are 0 and 1. Each row is sorted in non-decreasing order. I'm kind of confused about what they mean here today. I feel like I've done it because of that thing. Because what I mean is that why isn't, with its rows sorted, is it just, or maybe rows sorted means some, maybe I'm confused a little bit. Rows of I is, okay. So basically, okay. So I think they could have kind of explained this really with one example, but I wasn't sure, because I think what I thought row sorted means is not what I think they mean. Row sorted just means that there'll be no zeros after ones, but I thought it may be something like this is not possible because it's sorted on the rows itself. But it seems like this is a valid input, and if that's the case, it's just binary search on the thing, and you can't really go. That's lower bound. But let me try to put this in here. Okay, so this is a valid input is what I was trying to say, because if it was not a valid input, then in theory I'll get another valid input, and then, you know. But I think this is pretty straightforward, to be honest, as a result. The bound is not that bad, it's just that you have to be a little bit careful. The idea of, because so the other thing that I was thinking was that because I thought that maybe it was increasing in the rows, so then in that case you just go to the last row, right? Because that's the biggest. So that's why I was a little bit confused about the misunderstanding or whatever. But in this case, you have to look at each row because there's no ordering between the rows, right? So for each row, you have to figure out how many ones there are, and to figure out how many ones there are or how many zeros there are, depending on how you want to say it. Yeah, you just binary search on a thing, and then you're only given a budget of 1,000 cores, but given that there are only 100 rows and the columns is 100, which you can do in like, 2 to the 10 is 1,000, right? So that means that we have more than enough cores. So we just have to, but this is a problem that forces you to do a binary search or like implement a binary search. So yeah, we can do something like for, is it 0 indexed or 1 indexed? They don't really tell you. They haven't even coded once. Oh, 0 index. Okay, they do tell you. Well, technically not in the API. Oh no, it's right here. Okay, fine. But yeah, here then we just maybe have a function that we will call. So we'll just go, let's just say, so we want the fewest zeros. So maybe we just do this, something like that, or maybe +1 even, and then we just do best is equal to min of best of calc of x for the row, and then just return best, something like this. Maybe we're off by 1, but I think we're fine. We should be okay. Is row a keyword? No, it's just that I can't tell if that's a color. Man, my eyes are bad. Okay. Yeah. So then here we just do binary search, right? So is we want the bounds to be inclusive, so it'll be this. Maybe we want it to be C just in case, because we want all of it. Okay. Okay, so then now if binary matrix dot get row of mid is equal to 1, right? Is it the number 1 or the? Okay. Sometimes they use string 1 and sometimes they use number 1. It's not clear. Okay, so that means that if this is a 1, then this column is a good column. Well, I mean, all off by 1, maybe, I don't know, because we want the number of. So okay, let's actually define more clearly what I want here, right? What we want is the column of the first 1. Okay, right? Fine. So that means that if this is a 1, then we want to search the left side, but this is a routed column, so right is equal to mid, otherwise else left is equal to mid +1, and then we just return left at the end because, yeah. Okay, I forgot that there's a -1, that's why. Yeah. Basically, if best is greater than maybe just greater than C, then we return -1. Is that true? Maybe I messed up here. If it's greater than C, that means that so can this be C? Maybe I need this to be +1. No, I think this is fine. Maybe. No. Oh wait, this, I think it's this. Okay. Because it cannot have, because the column cannot be C. The number of 0, because once again, I was confusing what I was defining in my head. And I was defining as the number of zeros, which there can be C zeros, but the first column cannot be C. So that's why. All right, let's give it a submit, and hopefully I didn't make a typo or anything like that. Cool. Yeah. This is very, very good. And of course, for each row, which is O of R, all rows, we do this binary search. And this binary search, of course, is O of log C. So this is O of, so in total, this is going to be O of R log C time and O of 1 space. We don't really use any space, right? Yeah. Binary search, should I go? I'll go through this a little bit more, which is that the way that I do it is that I use inclusive bounds. So you have to figure out whether you want inclusive bounds or exclusive bounds. But for me, I use inclusive bounds because that means that when the range is 1 number, then we know that that's the answer that we're looking for. here, as you kind of saw, well, if the middle of if the number that we're testing is in the results that we want, then we just basically remove whichever half that matters. And here we remove the right half to, because if there's a 1, we want to look at the smaller, the left half, because that's the one we know that the answer is in that half of the number, right? And we set it to mid instead of mid minus 1, because mid is an answer, because we want it to be 1. If you wanted to change the definition a little bit to 0, then for example, then you might have to modify these as well. But yeah, that's pretty much all I have. So yeah, let me know what you think. Stay good, stay healthy, to good mental health. Hope y'all keep your streak going, all that stuff. I'll see you later and take care. Bye-bye.